right, so this is going on page 153 when we're done. Now, I had you write this definition out yesterday because it wasn't on those other notes and it really bothered me. And then it didn't occur to me that I was going to have another set of notes anyway. So you're going to have to write it on your homework anyway. I just pretty much gave it to you. But let's go ahead and put it here in our notes. The actual definition. Oh, and I put set. I can't believe I did that. All right. Well, I did. That's okay. So a parabola, we're going to change the word, is the set of all points. What's another word for set? Locus. Maybe it's better that you have to actually write it. No T on the end. It's not a bug. Okay. A locus, a set of all points in a plane. Remember, it's two-dimensional. If I take that parabola and I hold it by its vertex and I revolve it around the axis of symmetry, that's when it makes the paraboloid that is in your lights and whatnot. Okay. So it's the set of all points in a plane that are equidistant from a fixed line. What's the line called? Directrix. Okay. Which, by the way, spell check doesn't think is a real word. And a fixed point not on the line called the what? Focus. Okay. So, and then the focus is always inside the parabola. Always inside. All right, so just quick review, plus I think these pictures end up being a little bit better to label. I had a really hard time, I had to fix this myself. On all the pictures, like I was trying to Google some decent picture that we could put on here that we could label, but none of them were to scale. Because the scale matters here on, you know, how big 2P and P is, and if it doesn't look right, it doesn't make any sense. And so we'll kind of look at that. I think I fixed it the best I could on Word, but you would be amazed how many bad pictures and bad everything is there out there. All right, so if it opens up or down, our standard form equation then, what is going to be squared if it's opening up or down, x or y? X. Okay, so we get x minus what? H squared, and that equals what? 4p, good, times y minus k. Okay. If it's opening right or left, that means y is squared, so that'd be y minus k, because k still goes with y, and that's equal to 4p times x minus h. Okay, that should be old business. We should know that, but it doesn't hurt to write it down and think about it. Think about what's really happening here. So we're going to use this picture here to label our names and stuff again, and then we're going to use the other one to label our lengths. So this point right here is the what? Okay, it's the focus, right? This point right here is the vertex. This line is the directrix. Okay. This thing right here is actually our parabola. Okay. Then this whole thing here is called the what? This whole segment here. This is the focal chord, or the other name for it, same thing, is the latus rectum. This just doesn't sound very nice. All right, so over here, we know that the distance from the vertex to the focus, right, so we'll label that, vertex, focus, and then our directrix. Our distance from our vertex to our focus is what? P. So this length is P. That's why that 4P is important. And this distance here is also P. The focal chord length, this whole length here, is how much? 4P. So from the focus to the parabola itself, and this segment here is always parallel to the directrix, this length right here is 2P, and this length right here is 2P. And it may not be perfect to scale, because I finally got frustrated, but there was a lot of them where it was saying those things were true, and when I looked at it, I thought, wow, that would be very confusing. It would be hard to understand that that's the case because when you graph it, it should look like that. But and they weren't even drawn by hand, so I don't know. But you pretty much, that is about the same, right? And that's what you want to visual what's happening with your parabola. Okay, we're all good on that? It's kind of all business anyway, right? So again, I know all this stuff was yesterday, which was also a review, but let's just fill it in anyway. Vertex is always HK, right? If I'm opening up or down, then we already know that the focus is P units away, but what's changing is the Y value, not the X value, right? Your X value stays the same, which is still H, just like the vertex. And this becomes K plus P. Your directrix is also P units away. If it's opening up or down, it's a horizontal line, which means it's a Y equals line, right? So Y would equal what? K minus P. And those are lowercase k's. I can't make a lowercase k no matter how hard I try. Axis of symmetry, if it opens up or down, is vertical, so it's an x equals line, and it would be x equals h, right? Whatever the x value is. And then your focal chord length is going to be absolute value of what? 4p. Okay, so we're going to add one other thing on here. That's the focal chord length. We also want the endpoints of the focal chord. Now, when we write it down with the H and K stuff, it looks like it's all complicated. Once you're graphing it, it's really not that big of a deal. But let's just think about what we have here. If this is HK, right, and then this is HK plus P, right, then if I'm going to find these endpoints right here, that Y value stays the same, but what happens with, how do I find this X value? Not times 2, minus what? 2p, and this one would be plus 2p. So my endpoints are actually just the H value plus or minus 2p, and then the Y value is the value of the focus, which is K plus P. So over here, vertex is still the same if it's opening left or right. The focus changes though, because now the X value changes, so this would be H plus P, comma K. Directrix is now an X equals line, and X always goes with H, and what do I do with P? Minus P, right? Axis of symmetry, when it's opening left and right, is a Y equals line, so just be Y equals K. And this one is the same. Ooh, not a parenthesis there. So then endpoints again. Right, well the endpoints of my focal chord, the X value is the same as the focus, so it's H plus P, but then the Y value, I'm either adding or subtracting 2P, so it's, H plus P, comma, K, plus or minus 2p. That one looks way more complicated, but if you understand the picture, it's not that big of a deal to figure it out. We all good so far? Okay. So instead of just finding this stuff like we did yesterday, we're also going to be writing equations given different information that we have. So here and then we have to find all the same stuff every time. So it says write the standard form equation, so we got to know what the standard form equation is, of the parabola described and find all missing info in graph, which should be not that big of a deal given what we have. So what we're given is the vertex. I'm going to go ahead and fill that in, 4, -2. And the focus, which is at 6, -2. So if I plot those things, if I go to 4, -2, that's my vertex. And my focus is at 6, -2. That should already tell me something, right? Is it going to open left, right, up, or down? Right, okay? So it opens right, which means I know then that my generic form is going to be x minus h. No, it's not. Dang it. Y, sorry. We know that that is wrong, of course. So y minus k squared equals 4p times x minus h. So I already have h and k. That's what this is right here. This is hk. So I got that much. I need p. Well, the focus is just h plus p, comma k, right? That's how we know what that is. So I know that 6 has to equal h, which is 4, plus p. So what's p? 2. Okay. I know there's other ways to figure it out from the graph, but if you don't have a graph, if you understand those relationships, we have found what we need. We've got it all. And so now I can go in there and figure out the rest a couple of different ways. I can graph the stuff. I mean, I can graph the directrix and then write it, or I can write it and then graph it. You need to be able to do both. So I know that the directrix, since it is it's opening right, it has to be is it x equals or y equals? X equals. So it's x equals, and the directrix would be x plus or minus p. Which one? Minus p. So it's the x value of the vertex, or it's the h, minus 2, which gives me 2. So I come over here and graph it. This is the directrix, right? And, or again, if what I knew without having to worry about that and figure it out from the numbers, if the vertex and the focus are here and the focus is 2 this way, then the directrix has to go 2 that way. Either way you do it. Axis of symmetry has to be a y equals line, and y would equal what? Negative 2, because it's just the k value of the vertex. Okay. Then the focal chord length is what? It's the absolute value of 4p, so it's 8, which means I can go and plot those points. From the focus, I go 1, 2, 3, 4 this way, and 1, 2, 3, 4 this way. So I can just take the focus, the y value is what's changing, okay? It's either plus or minus 2p. So this would be 6, comma, and then what? I'm gonna add 4 and subtract 4. So let's start with adding 4. What's negative 2 plus 4? 2. And then it's also 6. Negative 2 minus 4 is negative 6. And I can get those points from my graph or from understanding how they work with each other. You with me on that? And again, you need both ways, because you may not always have a graph there. You could always sketch it yourself and figure it out, even if it's not beautiful. If you can't do it by counting, do it by the thought process there. Make sure that you have your vertex and your focus labeled. I didn't make you do that yesterday, but I should have. And then I sketch this in. We've done a whole lot. What haven't we done that the directions told us to do? What directions say to do? Write the standard for me. We've graphed it. We found all this stuff. Did we actually write the equation? No. Do we have all the stuff we need to? Yes. Okay. So this is just going to be y minus the k, which is a negative 2, so plus 2 squared, plus 4p. Now be careful just grabbing this number here. In this case, is it just this number? Yes. Is it possible that it could be different than this number? Yes, because it could be negative, so just be careful with that. Not plus. Equals, sorry, equals 8 times x minus h, which is 4. So here's my equation, and there's all my other stuff. We all good? Any questions? All right. So now let's look at this one. So now on this one, we are given the focus, which is at negative 3, negative 2. So I'll go and graph that. 1, 2, 3, 1, 2. So that is my focus. And then directrix at x equals 1, which is right here. Directrix x equals 1. So if I'm given those two things, does this open left, right, up, or down? Left. Okay, so it opens left. So is it x squared or y squared? Y. So then it's going to be y minus k squared equals 4p times x minus h. All right, so they didn't give me any of the things that go in there, but I can figure them out if you understand how the focus works, right? So then the focus is just h, and then plus or minus p? Plus p, comma, k. Now, that's all fine and great, but still not really sure how much to add or subtract, right? Well, the directrix is just going to be x equals h what? Minus p. So on your graph, you can count, okay? Yes, I understand we can go over there, we can figure it out. It's really not that big of a deal. But sometimes you can't count from your graph, so you've got to understand how to figure it out a different way. You with me on that? So I know the k value of my vertex. What's the y value or the k value? Because it's just -2, right? So for the vertex, I know the y value is -2. The h value is really just the average of these two x values. Does that make sense to you? So if I just take -3 plus 1 and divide by 2, it gives me a -1. You understand how it's just the average of those? Okay. Which again, I know you can get from counting. You're like, why can't I just count off the graph? You can, but if I don't have a graph and I can't count, you need a concept of how to figure it out too. This -1. And you can make yourself a little system of equations and do all that stuff too, but just, make sure you know what's going on here. So now that if I have that, can I figure out what p is? What's p? It's 2, right? Okay. Is it positive or -2? -2 because it's opening left, right? So this is a -2 because when I do h plus p, that would be -1 to get to -3. I'd have to subtract 2, so p has to be a -2. That's important, right? We also know that it has to be negative because it's opening left, so you can kind of check yourself that way in case you get mixed up on the numbers. All right, now that I have all of that, axis of symmetry is going to be a y equals line, and y equals what? -2. What's my focal chord length? 8. Because it's the absolute value of 4p, and p is a -2, so it's 8. So I can come over here, and from my focus, I can go 1, 2, 3, 4. Focus, 1, 2, 3, 4. So for the endpoints of the lattice rectum, notice I use the different words, but it's the same thing. Okay. The endpoints then are going to be at -3 something and -3 something, right? And I just take that focus point and the y value, and I add or subtract how much? 4, right? Because it's 2 times, well, -4, it doesn't matter because you end up doing both. So this is going to be at a +2 and -6. Then I can go and draw this in. I did not draw my axis of symmetry. I don't think I did on the last one either, but we need to draw that in. There's your axis of symmetry. Maybe I did on the last one. So once again, I've done everything except write the equation. So I got to make sure I write the equation. Go back up here, and I've got y minus k, which is a -2, so it's +2 squared, equals what? 8 or -8? -8. It's negative because it's opening left, times x minus a -1, which is +1. Everybody okay with that? We're all good? Yes? Awesome. All right. So in this one, we're given the vertex and the directrix instead of the focus and the directrix. So I'm going to go substitute that in. -4, 1 for the vertex. Directrix, y equals a -2. So -4, 1. That is my vertex. Make sure you're labeling them so you're using the right thing. -2. That is my directrix. Okay. That is a negative. No, that is a -2. Did you do that right? Why do I feel like that's wrong? Okay. All right. Everybody good so far? Now, is it opening left, right, up, or down? Up. So that means that x is squared, right? So x minus h squared equals 4p times y minus k. That's what I'm substituting it into, and it opens up. So what is p? Three, okay, because your directrix is y equals k minus p, right? So negative 2 equals 1 minus p. So p has to equal 3. That's how you figure it out if we're not counting on a graph, right? You find the information that you have, and you got to know k and p and h wise how to find it so you can figure out what you need, especially if the numbers are weird and it's not something that you can count. Okay, are we all okay on how I found that? Yes, because we know that this is how you find the directrix, right? And then I just substituted that in there and the k from there. Okay. So p is equal to 3, which means the focus is going to have the same x value, negative 4, and then it's k plus p, which is 4. So negative 4, 4, there's my focus. Okay. Axis of symmetry is going to be an x equals line, and it's x equals what? Negative 4, good. There's my axis of symmetry. Focal chord length is what? Absolute value of 4p, so that means it is 12. So from my focus, not from my vertex, from my focus, I can go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There are the endpoints. So the x values are what are changing here, not the y values. So my 2 points have the same y value as the focus, not as the vertex. So the value is 4 on both of them. And then the x value is the h plus or minus 2p. So negative 4 plus or minus 6. So negative 4 minus 6 is negative 10. Negative 4 plus 6 is positive 2. And that's what we already had graphed. So then I can sketch that in. Bam. There we go. I have all of my pieces. So I can come back here, make sure I substituted in correctly, and I get x minus a negative 4, so it's x plus 4 squared, equals, I know it's this number, but is it positive or negative? Positive, because it opens up, because p is a positive 3. So this is 12 times y minus 1. Okay. Any questions at all? We all good? All right. Is all this a review? Yeah, okay. That's a good thing, right? It's not necessarily a bad thing. All right, so now we have this vertex, 2, negative 3, and it goes through 10, 5, and has a horizontal axis of symmetry. All right, so vertex is at 2, negative 3. I'm going to plot that. 2, negative 3. There's my vertex. It goes through 10, 5. So 10 goes through 10, 5. And it has a horizontal axis of symmetry. So since my vertex is at 2, negative 3, my axis of symmetry is right here. Which means I already know what my axis of symmetry is, yes? Okay, axis of symmetry is y equals negative 3. Now, since the axis of symmetry is just y equals k, the only thing I need to write the equation is my h and k, which I have, and p, but I don't have that. Now, this opens left or right? Right, right? And I know that because I have this point right here. So I know it's not, this is my axis of symmetry, so it's opening, it's going to look something like that, right? So I know that it's opening right, which means that I'm going to use a y again. So y minus k squared equals 4p times h minus k. X minus h. X minus h. My goodness. All right, so what do you think I can do to figure all this out? Any ideas here? I can substitute it in, right? Because I have an x and a y, and I have an h and a k. So this vertex is my hk. The point that it goes through is some xy, and I can replace all of those and figure out what p is. I'm going to do this down underneath, though. I think you have more room underneath than you do right there, so I'll do that there. So we'll take this, the x, which is 10, minus the h, which is 2, squared, equals 4p, which we don't know, times y minus k, 5 minus a negative 3. Am I doing this wrong? What did I do? I put the x first? Dang it, what the heck? Okay, sorry. That's why I can't see it, and you just stopped me. I did it backwards. Okay, dang it. All right, let's start over. It's y, it's because I couldn't see up there. Y minus k first, okay. So y, which is 5 minus a negative 3 squared, equals 4p times, I should just not even teach, and y'all could just be fine without me. 10 minus, sorry, 10 minus 2, thank you. All right, so now that's correct, yes? All right. No? Stop it. All right. Now, but don't go too crazy with this, because I don't need to go too far. Here's what I mean by this. This gives me 8 squared, and that's equal to 4p times 8, right? And I'm going to leave this side like this for right now, because what this tells me then is that 64 equals 4p times 8, right? Now, at some point, don't I want 4p? Like, I want to know exactly what 4p is. So if I just divide this out, 64 divided by 8, I get that 8 equals 4p, which is important to me at some point, right? That's part of my equation. And then I also do need p. What is that? 2. Okay, like I need both. So instead of trying to find p and then multiplying it by 4, again, I know it's not hard to multiply by 2, but if your numbers aren't as pretty or you get weird things, if you can stop, and that's a part of substitution that you have right there. So if we stopped right here, we could go ahead and write our equation. Just go ahead and do that. I know that 4p equals 8, and it is a positive 8 because that's what I got when I substituted it in, once I finally did it right. So when I come back over here, then a negative 3, which is y plus 3 squared, equals 4p is 8 times x minus 2. Does that make sense to you? So then p, I mean, it's fine to find p and then substitute it back in. There's just times where you want to kind of simplify your life a little bit. So p equals 2, which means my focus, okay, what changes on my focus, the x or the y value from the vertex? The x. Okay, so the y value is still negative 3, but for the focus, I add the p to the h value, so this gives me 4. Okay, so at 4, negative 3, there's my focus. My directrix is going to have to be an x equals line, and then that's going to be my h minus p, so 2 minus 2 is 0. And that is the y-axis. Right, this is my directrix. My focal chord length is what? 8. Right. So from the focus, so 1, 2, 3, 4, 1, 2, 3, 4. So in this case, my x values are the same as the focus, so they're both 4. And then I take the y value and I add or subtract 2p. So when I add it, I get 1. And when I subtract it, I get what? Negative 7? Good. And then when I sketch it, I have a bonus point over here, right? I can go through that point right there to get my shape even better because I missed over there. And we're good. Okay, everybody good with all that? Okay. Any questions? Those are all the different types of things that could happen here. Now, when I give this to you, I want to tell you once again, It's like, oh my God, I'm getting a packet. But you're getting a packet instead of a single-sided sheet that has a ton of extra stuff on it that you then have to go do on a separate sheet of paper. I gave you graphs that you could actually graph. So it's spaced out. That's why it looks like a bazillion problems, and it's really not.